Good evening, children. Good evening, Lakshana and Ariston.
Good evening, ma'am.
Good evening. Can you see my screen? Both of you?
Yes, ma'am.
Yeah. All right. So today will be the concluding session on mensuration. Now this question, a road roller takes 750 complete revolutions to move once over to level a road. We have not done this presentation, right, children? Just have a look at the questions. Road roller 750, then this thickness of a metallic tube. I think Lakshana has been attending the classes regularly. Lakshana, you can help me?
We haven't done it.
We haven't, right? Look at the next one. An iron pipe 20 centimeters long has exterior diameter 25 centimeters.
No, ma'am, we haven't done it.
Okay. Yeah, see. So a road roller takes 750 complete revolutions to move once over to level a road. Okay, so if the road has to be leveled, the road roller has to make 750 complete revolutions. Find the area of the road. Now the road is rectangular. If you know the length of the road and the breadth of the road, you can find the area of the road. But here the length and the breadth of the road, see, road is rectangular, right? So if you know the length and the breadth of the road, you can find the area of the road. But here the length and the breadth of the road is not given to you. Something is given about the road roller, which is cylindrical. How do you know it is cylindrical? Because it's given that the diameter of the roller is 91 centimeters. Diameter means there is something circular. Only when there is something circular, we'll have this diameter. Otherwise, how will you have diameter? When the solid or when the object has nothing circular in it, then there is no radius or diameter. So because diameter is given, that means there is something circular. And length is given. Length is 1.25 meters. So the road roller is cylindrical. The road roller is cylindrical, and we have seen that, no? We have seen that the tar being poured on the road, and then the road roller rolls over it to level the tar, that thing which is poured on the surface. Yeah. So find the area of the road if the diameter of the road, if the diameter of the road roller is 91 centimeters and the length is 1.25 meters. Now, when the road roller, the cylindrical thing, rolls over the ground, the curved surface area, only this one, the curved surface area of the roller rolls over the ground, correct? Only the CSA, the curved surface area, rolls over the ground. So the distance covered, the area covered in one revolution will be equal to the CSA of the road roller. The area rolled on the ground, the area rolled on the road in one revolution will be equal to the CSA of the road roller. Now the road roller has to make 750 revolutions to level the road. That means the area of the road is the area covered in 750 revolutions. The area of the road is the area covered in 750 revolutions. The area covered in one revolution is CSA. So in 750 revolutions will be CSA into 750. You can see here. So we start with finding the CSA of the road roller. CSA of the road roller, 2 pi RH. It's cylindrical, so CSA is 2 pi RH. The radius is given. The diameter is 91 centimeters, so radius is 91 by 2. The diameter or radius is in centimeter, but the height, the length of the cylinder is given in meters. So convert that also to centimeter. So the height is 1.25 meters, convert that to centimeter. So 1.25 into 100. How do you convert meter to centimeter? We multiply by 100. How do we convert meter to centimeter? We multiply by 100. So here we multiply 1.25 into 100. So it's converted to centimeter. So the height of the road roller is 1.25. The height of the road roller is 125 centimeters. Diameter 91 centimeters. So radius 91 by 2. Height is the length 1.25 meters. Convert that to centimeters. So into 100. So we have the radius and height. So substitute that in 2 pi RH. Substitute for R and H and find CSA. And the CSA will be in centimeter square because we have the values in centimeter. So the CSA you find will be in centimeter square. Now the area of the road is the CSA of the roller into the number of revolutions. Whatever is the CSA of the roller into the number of revolutions. Because when you find this, you know what the CSA of the roller is? It is the area covered in one revolution. The CSA of the roller gives us the area covered in one revolution. This is the area covered in one revolution. So if you multiply this one with 750, you will get the area leveled in 750 revolutions. And that is the area of the road. And that will be the area of the road. So the area of the road is equal to CSA of the roller into the number of revolutions. So CSA into number of revolutions. So you get the answer in centimeter square. Okay, convert that to meter square. See, now how do you see here? Why did we convert meter to centimeter? Because radius is in centimeter. So we have to convert height also to centimeter. You can also convert the centimeter to meter if you want. That's your choice. You can convert 91 by 2 centimeters also to meters. Normally we convert to the smaller of the two units. Well, when we use the values of R and H, we normally convert it to the smaller of the two units. Centimeter, meter. Which one is smaller? Centimeter. So we convert it to centimeter. So the answer you get here is in centimeters square, but this is really large, such a huge number it is. So you can convert that to, you can try converting that to meter square. Meter square. So to convert centimeter to meter, we need to divide by 100. To convert centimeter square to meter square, you need to divide by 100 two times. So divide by 100 into 100. Divide by 100 two times. So when you divide this one by 100 two times, 100 into 100 or by 10,000, the area in centimeter square is converted to meter square. So now how do you simplify this? Just shift the decimal point. So you can cancel the 0 and 0. 0 and 0 you can cancel. And then 2 zeros. No? So shift the decimal point. It will come here. 2681.25 meters square. This 0 and these two zeros and these two zeros gets cancelled. And now these two zeros, shift the decimal point of the numerator. Here, 2681.25 meters square. This is understood? Lakshana and Ariston?
Yes, ma'am.
Yeah, both of you please take screenshots. I'll just explain all the 4 sums and then you can start working them. So when we have to find the area of the road in a situation like this, when the road is leveled using a roller, you should find the CSA of the roller and multiply that with the number of revolutions. Find the CSA of the roller because that is the area leveled in one revolution. So multiply that with the number of revolutions. That will be the area of the road. The thickness of a metallic tube. The thickness of a metallic tube. I've shown this, image also. Like I use a sellotape roll to explain this. Can you recollect that, online students, Lakshana and Ariston? Oh, okay. The others have joined now. Gayatri, Shriya, and Anantika. Good evening, Gayatri, Shriya, and Anantika.
Good evening, ma'am.
Good evening. Okay. Let me just show you the presentation, I think. Yeah. So the second question we are talking about this pipe. Yeah, we are talking about a pipe like this. This pipe. You can see it's cylindrical. This pipe is cylindrical. And you can see that the wall of the pipe is thick. The ends are open. Both the ends are open. Both the ends are open. This one is a pipe. It can be made of it can be made of any material, fiber, metal. So this is the pipe we are talking about in question number 2. The pipe is open at both the ends. And the wall of the pipe is thick. You can see the thickness here. The wall of the pipe is thick, which gives us 2 radii. Okay. So from the center to the inner wall is the inner radius, smaller. From the same center to the outer wall is capital R, the outer radius. And this is the thickness of the wall, which is given by R minus R, represented by the letter W. W is equal to R minus R. W is equal to R minus R. This one, thickness is represented using the letter W. There's no W in thickness, like width. So that W, width, thickness. From that we get W. So you cannot say thickness is T. This letter only you have to use, W. It's from width, but we normally say thickness. So the thickness W is R minus R. So if the external radius is 10 centimeters and the internal radius is 7 centimeters, that means 3 centimeters is the thickness of the pipe. External radius 10, internal radius 7. External radius 10, internal radius 7. So 10 minus 7, 3 is the thickness of the pipe. So supposing you're given only the internal radius and the thickness. Supposing you're given the internal radius, this one is say 4, and the thickness is 1. So the internal radius is 4, the thickness is 1, then what will be the value of capital R?
5.
5. Correct. 5, because 4 plus this thickness is 1, no? So 4 plus 1, capital R is 5. Capital R, because, okay, we should. Yeah. See this thickness is from here to here. This is 1. This is 1. So this is the external radius. 4 plus 1, 5. Not 41. 4 plus 1, 5. Now supposing we have the external radius given. External radius is given. This one says like 13. Capital R is 13. And the thickness is say 2. Capital R is 13 and the thickness W is 2. Then what will be the value of small r?
12. So 11.
11.
Sorry.
11.
11.
13 minus 2. Correct. 13 minus 2, because from here to here it's 13. Minus 2. Minus 2. So the internal radius is 11. From here to here it is 13. 13. Minus 2. This is 2. So take away this. Take away 2. So 13 minus 2 is 11. And see, you can see that's the internal radius, 11. Okay. But the height, so there'll be 2 radii. One internal radius, one external radius. But height, when it comes to height, there's only one height h. There's nothing like internal height and external height. The internal height, the external height, both are the same. Radius will be different. The internal radius is different from the external radius because the pipe is thick. The wall of the pipe is thick. But the internal height and the external height will be the same. H is only one h. So you can see here, this is the formula to find the volume. If you have to find volume, this is the formula to find volume. Pi h into capital R square minus small r square. pi h into capital R square minus small r square. This is the formula to find the volume of the material in the hollow cylinder. Ring, we spoke about the rings. The area of the ring, this is a ring. If you want to find the area of this portion, this one. If you want to find the area of this one, this is a ring. A similar ring is on the other end, which is not visible in this picture. A similar ring is on the other end of the cylindrical pipe. So the area of this ring is given by pi r square minus r square. Pi r square minus r square. So there's a ring on the other side. So that area is also pi r square minus r square. Area. And then there is another surface. Inside there is a surface. No, that's the curved surface area. Inside the internal CSA or the inner CSA is given by 2 pi small r h. Then this outer CSA, outside curved surface area, that is given by 2 pi capital R h. So these are the different surfaces you can see. See, when we talk about solids, we talk about their volume and area. When we talk about solids, we talk about their volume and area, meaning the curved surface area or the total surface area. Okay, so we're trying to understand the surfaces. We have seen this earlier, children. I'm repeating this. Volume, there's only one volume. This is the formula. Pi h capital R square minus small r square is the formula used to find the volume of the material. Is the formula used to find the volume of the material in the cylindrical shell. So if you have to find how much of, now supposing this cylindrical shell is made of iron. Okay, what is the volume of iron? Volume of iron. Now supposing this pipe, this is called a cylindrical shell or a hollow cylinder. If you have to find the volume of iron used to make this one. Yeah. Okay, so if we have to find the volume of the material, the volume of the iron used to make this pipe, then you'll have to use this formula pi h into capital R square minus small r square. This formula will help you to find the volume of the material. How much material is used in making this pipe? That's about volume. Pi h into capital R square minus small r square. That's over. Now talking about the different surfaces we have in this pipe. Talking about the different surfaces. Just imagine a pipe like this. Where all can you touch this pipe? You can feel its inner CSA. Then you can feel its outer CSA. Then the two rings on either ends. These are the four surfaces you see in the cylindrical shell or hollow cylinder or pipe. If you have to rub your hand over this pipe, where all can you feel the surfaces? You can feel the inner CSA. You can touch the inner CSA inside the pipe, the inner CSA. Then outside, the outer curved surface area, outer CSA. Then you can see the two rings. One ring which is visible to us here. This one ring. This is called a ring. This area is called area of a ring. And you can see a similar ring behind. Similar ring you can see behind. So if you have to find the area, the surface area, the total surface area of this pipe, then you'll have to find four surface areas. That is the inner surface area, the inner curved surface area, the outer curved surface area, area of one ring into two to find the area of two rings. If you have to find the total surface area of this pipe, you should find the inner curved surface area using this formula 2 pi small r h. Then you should find the outer curved surface area using this formula 2 pi capital R h. Then you must find the area of the two rings. Okay, one ring pi. Second, yeah. One ring is pi capital R square minus small r square. Two rings, you just multiply that answer by 2. And add all this, you will get the total surface area of this pipe. Since I was talking about, yeah. Let me do the third one. Since I just finished with surface area. Since I just finished with surface area, let me just explain 3 which is related to surface area. Okay, I'll just show you the answer. See here. I'll go back to the second one, children. I'll go back to the second one. Now you can see here an iron pipe 20 centimeters long. So that means the height is 20 centimeters. External diameter 25 centimeters. External diameter means external radius, capital R, will be 25 by 2. External diameter. So external radius, capital R, will be half of the diameter, 25 by 2. Thickness, 1 centimeter. So W is 1 centimeter. Then how do you find the internal radius? External radius minus W, minus the thickness. So 25 by 2 minus 1. Take the LCM. And you get 23 by 2. So like this, you should read the question and write out the values you need to apply in the formula. So an iron pipe 20 centimeters long. So H is 20 centimeters. You can write it here in the first place itself. You can write H20 here itself. Not that you should write it here. Okay, you can start off with H is equal to 20. Okay, so H is 20. External diameter. That means the external radius you can find. Half of this is the external radius. That means capital R. Thickness, W, 1 centimeters. Now the internal radius is not given, but you can find how external radius minus the thickness. So 25 by 2 minus 1. Take the LCM and you get 23 by 2. Now we have all the values we require to find volume or surface area for the pipes. But the question is to find the whole surface area. Find the entire surface area of the pipe. So see here, as I told you, find the inner CSA, find the outer CSA, and find the area of the 2 rings. And add everything. Add everything. That will be the whole surface area or the total surface area of the iron pipe. So as you do, please memorize the formula. CSA 2 pi RH. Inner CSA. Outer CSA, capital R you should use. Area of 1 ring into 2 will be the area of 2 rings. I found all the answers in pi. I have not substituted the value of pi. I have not used 22 by 7 anywhere. I found every answer in pi. And then TSA is equal to answers we got in 1, 2, and 3. So that is 1008 pi. Now once for all, I've used the value of pi, 22 by 7. Then you can see I've cancelled 7 ones are 7, whatever. Yeah, so this is about finding the surface area for a pipe. Okay. The first one was about very important questions. All these are. This one was about finding the area of the road, which is leveled by a roller that is cylindrical. This question is finding the area of a road. Length and breadth of the road not given. Okay, but still we're able to find the area of the road using the number of revolutions the roller takes to level the road. So this is, one of the many important questions. And then third one was about finding the total surface area of a hollow pipe. The second one is similar. It's about volume. So you will help yourself to write all this. All this you can help yourself now because you know now inner diameter means inner diameter you can get inner radius smaller. Inner diameter, so you can get inner radius. Here, thickness is 1 centimeter, so W is 1. Inner diameter, so inner radius is 12 by 2, 6. So you know the thickness and you know the inner radius. Then you can find the outer radius. That need not be given to you in the question. You can find it yourself. So the outer radius is inner radius plus the thickness. You can just draw 2 circles like this and understand. From here to here is 6. Inner radius. The thickness is 1. So the external radius is 6 plus 1, 7. Okay, and height is 1 meter. But since the other values are in centimeter, we convert that to centimeter. All the values must be in the same unit. So 1 meter, which is 100 centimeters. All right. Now volume formula is this one, substitute the values, and this is what we get. Now the question is, find the weight of 1 meter long. So, okay, yeah. So the height is given here, h is here. Find the weight of 1 meter long tube. That means the height is 1 meter. Find the weight of 1 meter long tube. So the height is 1 meter, 100 centimeters. If the density of the metal is 7.8 grams per centimeter cube. Now the question is, okay, we've written all the values, W, small r, capital R, H, but how do you know that you have to find, volume or surface area? That is very evident from the information given in the question, that you can easily make out from what is given in the question. You see what's given here, 7.8 grams per centimeter cube. And this is the unit for volume. This is a unit for volume. If it is centimeter square, it is unit for area. Centimeter cube is a unit for volume. Centimeter cube is a unit for volume. That means here you'll have to find the volume of the pipe, the volume of the tube, metallic tube. So this is the volume, 1 per centimeter cube. 1 centimeter cube, 7.8 grams. So many centimeter cube will be this one into 7.8. Like one book, 10 rupees. 70 books will be 70 into 10. Similarly, 1 centimeter cube. This volume, 1 centimeter cube, has a weight of 7.8 grams. But the real centimeter cube is this one. For 1 centimeter cube, it is 7.8. But for so much centimeter cube, how much is the weight? So this one into 7.8. So for this question, we have all the values. But the thing is, should we find area or volume? It is volume because it's given the metal weighs 7.8 grams for every centimeter cube. So 1 centimeter cube of metal weighs 7.8 grams. So you should find how many centimeter cube is there in this tube. So you should find volume. So you should write all these. This is very important. Reading the question. As you read, you should write. As you read the question, write out these details. These details, as you read, keep writing the details. Then find volume. And then you can see here, 1 centimeter cube, 7.8 grams. Then so much centimeter cube, how many grams? So 7.8 into this volume you found. Simplify that and you get the answer in grams. Convert that to kilograms. Convert that to kilograms by dividing by 1000. Convert that to kilograms by dividing by 1000. So you can see here, I multiplied and then 7.8. No, so I've written 78 by 10. I don't want a decimal point. So I write that as 78 by 10. So the 78 by 10 is not converting to something. Shifting the decimal point. 7.8 we are writing as a fraction. 78 by 10. So then cancel. 0, 0 gets cancelled. Yes, then nothing else. You can simplify. So multiply. You get this. And then you'll have to divide by 7. So you get this one approximately so many grams. Now divide this by 1000 to convert it to kilograms. When you divide by 1000, you're converting it to kilograms. So now you should just shift the decimal point. It's here. 1, 2, 3. 31.868. Whenever you're dividing by 100, 10, 100,000, just shift the decimal point. You don't have to actually do the long division. Just shift the decimal point. 1, 2, 3. 31.868 kilograms. So that's about the second one. Yeah, online children, have you taken a picture of the first one?
Yes, ma'am.
Okay,
Yeah, ma'am.
good. Yeah, this is the second one. Take a picture.
Yes, ma'am.
Okay.
Taken, ma'am.
Yeah. 3, I've explained this. Take a picture.
Done, ma'am. Taken.
Yeah. Second question is about volume. Formula is different there. This one is about area. So that's all they can ask you about a pipe or a tube, which is called a hollow cylinder or a cylindrical shell. These are the only two questions that can be asked. Yeah, this you can do it yourself. Yeah, take a picture, online students. Done?
Yes, ma'am.
Yeah, okay. Let me just make sure that because you missed last two classes, right? Yeah, okay. So the question is, children, how many square meters? What do you mean by square meters? That's a unit. How many square meters mean? That's a unit. So again, square meters is a unit for area. So you'll have to find area. How many square meters? That is area. So what area of metal sheet? The question is what area of metal sheet? How many square meters? Square meter is nothing but meter square. Meter square. This is nothing but meter square. So how many meter square means? Or they're asking you to find the area. Find the area. So how many square meters of metal sheet is required to make an open cylindrical drum? Is required to make an open cylindrical drum. So it is cylindrical, okay? It's a cylindrical drum, but it's open at the top. So where will the metal sheet be used? This drum is made using metal sheet. And where all is the metal sheet used? It is used to make the CSA of the drum. It is used to make the base, the bottom of the drum. But since the top is open, there is no material used on the top. And when you find area, you will find the area only if material is used there. If no material is used, then what area are you finding? So here, this one is a cylindrical drum, which is open at the top. So the metal you will use, now supposing you have to make a cylindrical, say a pen stand. So you'll make it open at the top, right? If you have to make a model of a pen stand using cardboard. So how will you make that pen stand? You will make a cylindrical pen stand. You will use the cardboard to make the CSA of the pen stand. And then you will cover the bottom. So where all will the cardboard be used? The cardboard will be used only to make the CSA of the pen stand and the bottom of the pen stand. The top of the pen stand is open. You are not using cardboard there. There's no cardboard on the top. In the same way here, the metal sheet is used only to make the CSA and the circular bottom. The circular bottom. So what area will you find? You will find the CSA of the drum and the area of the bottom. CSA of a cylinder is 2 pi RH and the bottom is a circle. So area is pi r square. Bottom is a circle, area is pi r square. So substitute the values here. Again, I've not used the value for pi. You can use children if you want. If you want, you can put it there. See, you can also find it separately like this. You can find CSA separately. Like you can work CSA separately, area of the bottom separately. Then you can say add both and find the area of the metal sheet used to make the drum. You can find it completely separately also. You can find work 2 pi r separately, pi r square separately. And if you want, you can use a value of pi 22 by 7. It will cancel 7 1s are 7 9s are 63. So all that experimenting you can do. It's not a hard and fast rule that you should not use the value of pi. I'm not using because when pi comes in multiple places, why simply use the value of pi and simplify and spend time? So I just go ahead with pi. So I get this answer in pi, add and again the answer is in pi. Now once for all I use the value of pi, 5229 into 22 by 7 and then simplify. So that will be the area. Now the cost, 1 meter square, 200 rupees. 1 meter square, 200 rupees. So many meters square, how many rupees? So it will be into 200. Is it fine? Online children, take a picture of this one. Done?
Yes, ma'am.
Yeah.
Done, ma'am.
So I'll come back in 20 minutes, children. Finish this. Write the question, read the question, understand the question, and work the answer. Go through the answer, understand, and then work it. And do the calculations. Just don't write it from what you see from the screenshot. Please calculate. You might realize that you have some problem with calculation also. So you can ask me. If you actually do it yourself, you can ask me. You can get them clarified. And if you feel why not use pi 22/7, please use. Please use. So all that you should do so that if you have doubts, you can get them clarified now. Yes, children, get started. I'll come back in 20 minutes. 20 minutes to half an hour, get started. Start working. Yeah, Anantika, Gayatri, Shreya, and Lakshana. What's the status? No hurry, but just update on your status. Lakshana?
I'm in the last test.
Yeah. Okay. Shreya?
I'm in the third one, ma'am.
Okay, yeah. Gayatri?
Here's the third one, ma'am.
All right. Anantika?
Ma'am,
Yeah, Gayatri?
completed, ma'am.
Yeah, good. Yeah, let's answer these questions, children. Try the first one, all of you. Take the first question and try it. The dimensions of a cuboid are in the ratio 5:3:1, and its total surface area is 414 meters square. Find its dimensions. So who can tell me the formula to find the total surface area of a cuboid?
LB 2 in LB plus BH plus LH.
Correct. So I've got it from Yarni. 2 of LB plus BH plus LH. So that is given. So to TSA, the total surface area is equal to 414. Below that, 2 of LB plus BH plus LH is equal to 414. Now what is L? Online students, what is L? How do you assume L?
5x.
5x. And B? 3x. And H?
X.
X. Yeah, substitute these and solve and tell me the dimensions of the cuboid. Please work. Got it?
Ma'am,
Yeah.
I got the length as 15 meter, breadth is 9 meter, and height is 3 meter.
15, 9, and 3, is it?
Yes, ma'am.
Okay. So what is TSA given to be? 414, right? 414. Below that, what should you do? Write the formula. 2 of LB plus BH plus LH is equal to 414. Then below that, 2 of what is L? What's the ratio given? 5x. 5x. So 5x into
3x.
3x. Then plus 3x into x plus
5x into x.
5x into x is equal to 414. Then 2 of 5 3s are 15. X into x, 3x square plus 5x square is equal to 414. Now the 2 will come down for division. And what is 15 plus 5 plus 3? 23. X square. Because when you add like terms, the answer also will be a like term. When you add like terms, the answer also will be a like term. X square, x square, x square, x square only the answer will be. When you add or subtract like terms, the answer also will be a like term. 23x square is equal to, that will come, the 2 will come down for division. So 23x square is equal to 207. X square is equal to 207 divided by 23. So x square is equal to 9. Divided, you will get 9. So x square is 9. So what is x? Square root of 9. That is 3. X is equal to square root of 9. X is equal to 3. So the length is L is equal to 5x. 5 into 3, 15 centimeters. B is equal to 3x. 3 into 3, 9 centimeters. And H is x only. That is 3 centimeters. Right? Yeah, you should be able to proceed. So for the others, this is the next question. Those of you who have completed the first one, if you want to take a picture, you can take a picture, online students. Those of you who have not completed, please do it now. Yeah, those who have completed can take the second one. Can try the second one. Three metal cubes with edges 6 centimeters, 8 centimeters, and 10 centimeters are melted together and formed into a new cube. Yeah, try. Find the volume and surface area of the new cube. So when, you know, one or more solids are melted and made into a new solid, their volumes will be the same. So what do we have originally? We have 3 cubes, right? We have 3 cubes. Please listen, online students, we have 3 cubes of different sizes because the edges 6, 8, and 10. So we have 3 cubes of different sizes. They're all metal cubes. The 3 metal cubes are melted and now formed into a new cube. Now so there's a conversion. 3 has become 1 now. 3 cubes have now become only 1 cube. So now these 3 cubes are melted and formed into a new cube. Now when this conversion happens, the volumes will be the same. The volumes will be the same. That is, the volume of the 3 small cubes will be equal to the volume of the new cube. It's like in 3 separate bags. In 3 separate bags, in this bag, there is, say 1 kg of fruits. In another bag, there's 2 kg. We'll say that the bag is very, very light. So the bag has no weight. Only the fruits in the bag has weight. There's another bag with 2 kg of fruits and another bag with, say, 3 kgs of fruits. You put all this in one big bag. Okay, so you put all this, that is 1 plus 2 plus 3, all this you put in a big bag. So what will be the weight of the new bag? 6 kgs. In the same way here, the volume of the 3 cubes will be equal to the volume of the new cube which is formed. What did you do? 1 kg plus 2 kgs plus 3 kgs is equal to 6 kgs, right? Similarly, volume of this cube with edge 6 centimeters plus the volume of the cube with edge 8 centimeters plus the volume of the cube with edge 10 centimeters will be equal to the volume of the new cube formed. That's the equation. Volume of the new cube is equal to volume of the sum of the volumes of these 3 cubes. So see here, volume of the new cube is equal to volume of cube 1 plus volume of cube 2 plus volume of cube 3. In the conversion process, the volumes will be the same, not the surface areas. The volumes will be the same. So this is the equation you need to write. When you read the situation, this is what you should write first. Volume of the new cube is equal to volume of cube 1 plus volume of cube 2 plus volume of cube 3. Now below that, how do you find the volume of a cube? A cube, edge cubed, edge cubed. Volume of cube is edge cubed, right? So I'm calling the edge of this cube as A. This one is A1, this one is A2, this one is A3. So cube everything to find their volume. To find their volume, cube everything. See, not that you should use A1, A2, A3. You can also use letters like, you can call this one as, A cube. And this one you can say X cube plus Y cube plus Z cube also. You can call the edge of this cube as X, the edge of this cube as Y, the edge of this cube as Z. And you can call the edge of this cube as A. So any letter you can use. And cube it to find the volume. You should cube the edge to find the volume. So I have used the edges capital A for the new cube, A1, A2, A3 for the 3 other cubes. Yeah. And then cube is for the volume. Why have we cubed everything? Because that's a formula to find volume. Okay. So volume of the new cube is A cube. Volume of cube 1, A1 cube. Volume of cube 2, A2 cube. Volume of cube 3, A3 cube. Now A cubed is equal to, we know the edge of all the 3 small cubes, 6, 8, and 10. So it will become 6 cubed, 8 cubed, 10 cubed, because we know the edges. So 6 cubed is 216, this one is 512, this one is 1000, and their sum is 1728. So A cubed is equal to 1728. A is equal to the cube root of 1728, and that is 12. So you know how to find the cube root. No, you can find it using the prime factorization method, 1728. Find it using the prime factorization method. 1728. So it'll be 2, 8 are 16, 6 and 4, 2, 4, 3, 2, 2, 2, 1, 6, 2, how many times? 108, 2. Now, if it is cubes from 3 equal factors, you should bring 1 out. From 3 equal factors, bring 1 out. Okay. Yeah, so from 3 twos, 1 2 out. From 3 other twos, 1 2 out. From these 3 threes, 1 3 out. So this will be the cube root. So 2 into 2 into 3. So 3, 2 to the 4, 4 3 is 12. So 12 is the cube root of 1728. You need to find the prime factorization of 1728. Use only prime numbers, not all numbers. Only prime numbers you must use. And start with 2. Finish with 2. Then if it is no longer divisible by 2, then use the next one, 3. If it's not divisible by 3, then 5. Not divisible by 5, then 7. Don't use random numbers like 6 and all that. 6 is not a prime number. You should not use 6. If you use composite numbers, you will not be able to find the cube root. You should use only prime numbers and start with the least. And then because it's cube root, from 3 equal factors, bring 1 out. If it's square root, from 2 equal factors, 1 out. So that's how we get 12. So 2 2s are 4, 4 3s are 12. Now the question is to find the volume and surface area of the new cube. Volume is here only. No, volume of the new cube is this one only. A cube, no? What is the volume of the new cube? A cube. This is volume. This is volume. A cube is equal to 1. This is only volume. You can find it again. You can find it again. You can find, if you want, you can write it again. Volume is equal to A cube, that is equal to 12 cube, which is 1728 centimeter cube. This is volume. The surface area of the new cube is 6a square. So 6 into 12 square, because the edge is 12. 12 square is 144 and 6 into 144 is 864. Right on, children?
Done, ma'am.
Yeah. Yeah, try this question. In a quadrilateral ABCD, you need to draw the figure and answer the question. In a quadrilateral ABCD, AB is parallel to DC. AB is parallel to DC. Also, you can see AB, DC, BC. Some values are given to you. Sides or diagonals, we don't know. We'll have to mark and see. AB is a side. BC is also a side. CD is also a side. Okay. So the lengths of these three sides are given to you. We need to find the area of the quadrilateral. Okay, so we have parallel sides and two equal sides. Let me first draw a rough figure. Okay, see, normally you can just no, when I say normally, I mean normally what I do. So I just use a rectangle. I name it whatever is given there, A, B, C, D. And then AB is parallel to DC. So let me just mark the parallel sides. And AD is perpendicular to AB. AD is perpendicular to AB. This is AD, this is AB. They're perpendicular. So I'll mark 90 here. And then AB is 8. This is 8. BC. DC is 5. BC is also 5. Find the area of the quadrilateral. Okay, so this one is 90 degrees. So now we have represented all the information in this rectangle. It's not a rectangle, children. The given figure is a quadrilateral. It's not a rectangle. I'll tell you what again I did. I normally represent all the information given in a rectangle like this. So name the rectangle. This is actually the quadrilateral ABCD. AB is parallel to DC. Okay. Then AD is perpendicular to AB. This is AD. This is AB. This is AD. This is AB. They're perpendicular means here 90 degrees. So this is 90 degrees. And then AB is 8. So 8. DC is 5. And BC is also 5. Now, use this figure to make the actual rough figure only. We actually can't make out how exactly the quadrilateral looks. That you can, show only by construction. This is the rough figure. For the rough figure, we are going to draw. This one is what I've drawn now is a rough figure. For the rough figure, I'm going to draw. How the quadrilateral actually looks like can only be constructed. So this is the rough figure. Now, with the help of this rough figure, I'm going to make the real rough figure for this answer. So the rough figure will be like, so just imagine if you're an artist, you can do it, like really well. Now look at this. This is 8, no, this is 5. So like I take a smaller line segment and a longer one, right? Because this is 5, but this is 8. And then this one, 8, this is perpendicular, so I need to take a straight line like this. Correct? And why this one is so small? Because this is 5 and this one is 8. And then I have to connect this like this. And this is also 5 only. So like this, we have A, B, C. Now while marking here, don't change ABCD. Don't put ABCD in a different order now. Don't mark ABCD like this now. You'll go wrong. The information in your figure will not match. So A, B, C, D like this. So this is you. So always when you read some information for which the figure is not given, simply draw a square or a rectangle and write out all the information in that square or rectangle. Then using this, you make the rough figure. Directly making the rough figure, see. Well, I cannot do it. Let me put it that way. I cannot do it. When I do this and then make the rough figure, I get it somewhat correctly. So I always use a rectangle or a square, mark all the information in this and use this to make the rough figure. So if you think, see, for children who can hold all this information in the mind and visualize, maybe you can make the rough figure directly. So that is your skill. Yeah, so I cannot hold all this information in my mind and make the rough figure. I can't visualize that. For me, it's difficult to visualize, putting all this in my mind and visualizing the figure and doing this directly. No, I can't do it. So I take the help of this figure and I make this. So now how to answer the question. Find the area of the quadrilateral. Quadrilateral area, we have a formula half D into H1 plus H2. Well, for that, the diagonal should be given. One of the diagonals should be given. Half D into H1 plus H2. No, we don't have information to use this formula. Now, what is a special name you can give this figure, children? One pair of opposite sides is parallel. So, what is a special name you can give?
Trapeze.
It's a trapezium. It's a trapezium. It's a trapezium, right? Okay. Because one pair of opposite sides is parallel. Now, what's the formula to find the area for trapezium? Online students, formula to find the area for trapezium? Formula to find the area for trapezium. Online students, use the emoji, raise your hand. Gayatri, Shriya, and Lakshana. Shriya, are you there, Lakshana? Yeah, formula to find, yeah, good. Formula to find the, what was I asking? Yeah, formula to find the area for trapezium.
Mom, h by 2 into a plus b.
Okay, h by 2 into a plus b. Okay, fine. Or half h into a plus b. Okay, half h into a plus b. Area is equal to half h into a plus b. Area of trapezium is equal to half into h into a plus b. A plus b, where a and b are the parallel sides, 8 and 5. And h is the distance between them. And the distance between them is AD, this one, the perpendicular distance between them. This we don't know. So what you have to do is you'll have to take a construction. What's a construction? Drop a perpendicular like this. Call it E. Now, what will be the length of EB? 3 centimeters. Because 3 centimeters. Because the whole thing is 8. But okay, if this is 5, this one is also 5. If this is 5, the opposite side, this is also 5. So the rest of it should be 3, no? If this one is 5, from here to here also is 5. But the whole thing, this one fully is 8. So this one will be 3. This one will be 3. So use Pythagoras theorem. Use Pythagoras theorem and find CE. You know A and B. A is 8 and B is 5. Use Pythagoras theorem and find CE and put that value here for H. That's the distance between the parallel sides. That's how you find the area of this quadrilateral. Yeah. Please use this slide. Complete this one, children. Or if you start with this rough figure, I told you, put it in a rectangle first. Yeah, we'll just understand this one and stop, children. So in this question, the area of a rhombus. See, I see this is in this answer, this involves using Pythagoras theorem. All of you understand how to apply the Pythagoras theorem? You must square the hypotenuse separately. CB is the hypotenuse. Square that separately. The remaining two sides, square and add them. Always square the hypotenuse separately. Write it on one side. So CB square on one side. On the other side, the remaining two sides, the CM and MB, square it and add them. So this will not work here, but I'll just tell you how to do it. You can complete this. The area of a rhombus is equal to the area of a triangle whose base and corresponding altitude are given to you. So if you find the area of the triangle, you can get the area of the rhombus. And to find the area of the triangle, what's the formula? What's the formula? Yeah, I got it from Yarni here. Half into base into height. Half into base into height is a formula to find the area of a triangle. So using that formula, half into base into height, base and height given to you, you can find the area of the triangle. And whatever is this answer is the area of the rhombus also. The area of the triangle, whatever you get, is the area of the rhombus. So now we know the area of the rhombus. Area of rhombus. We know it. Okay, so actually when you work, you'll get 240. Area of the triangle, you'll get 240. So area of the rhombus is also 240 centimeters square. Okay. Now, if one of the diagonals of the rhombus is 20, find the length of the other diagonal. Okay, one of the diagonals is 20, find the length of the other diagonal. What's the formula to find the area of a rhombus? Half into D1 into D2. Half into D1 into D2. This is the formula to find the area of a rhombus. Half product of diagonals is equal to 240. You found the area of the triangle. The area of the triangle is the area of the rhombus. Now area of rhombus is 240. And the formula to find the area of the rhombus is half D1 D2 is equal to 240. And we know the length of one diagonal, 20. See, one of the diagonals is 20. So you can find the other diagonal. You can find the other diagonal. So 2 and this gets cancelled, 10. So D2 is equal to 240 divided by 10. Correct? So D2 is equal to 24. So the length of the other diagonal is 24 centimeters. Yeah, online children, please take a picture of this question. Complete this answer. Yeah. All right, online children. That's it for today's session. Finished? Yeah. That's it for today's session, children. Thank you, Shreya, Lakshana, and Gayatri. Good night.
Yeah. Thank you, Mom.
Thank you. Yeah. Thank you.